Dear students, hope you have clearly understood the line clipping algorithm. And now we will try our hands at a numerical which has this statement. Clip a line with extreme points 150, 100 and 180, 10 against a window described as 1020 and 300, 200. So now first of all, read the statement very carefully. It's obvious that these two are the first and second extreme points of the line to be clipped, and these are the points describing the window boundary. So now let's draw a diagram, approximate diagram of this window, as 1020 is the first extreme point of the window and the maximum x max and y max point is given. This is x min and y min, this is x max and y max. Now we want to clip a line with extreme points having 150, 100 and 180, 10. First of all, you categorize the case. You categorize the line which we had discussed in the previous video. Which category does it fall? We will check. First of all, step 1 is find out its extreme points. First extreme point is 150, 100. So 150 lies between x max, x min and y min. So x min is 10 and x max is 300. Similarly, y min is 20 and y max is 200. So this point 150, 100 satisfies all the equations. So this means that the point 150, 100 is somewhere inside the window, and the second point 180, 10. So let's check whether it is inside. X coordinate, I'm taking x coordinate 10, and minimum value of x coordinate is x min is 10 and x max is 300. It's satisfied. Similarly, y for y 10, it should lie between 20 and 200. This condition is not satisfied. If you remember, any of the condition dissatisfied means that the point is outside the window. So now we can categorize it. First point is inside the window and the second point is outside the window. I approximately mark the points 150, 100. This is 10. X value of this point is 10. X value of this point is 300. So 10 and 300, and we need 150. It should be somewhere in between the middle. And similarly 100. This is 20 and this is 200. So 20 and 200 somewhere in the middle will be almost 100. So if I with approximately mark this location, this is 150 and 100. And the second point is outside the window. Its x coordinate is 180. So 180 will be between 10 and 300, but it will be to the right of the 150. So it will be somewhere like somewhere here. And y value is 10. Y value for the second point is 10, and y value for this line is 20. So it will be above it. So it might be somewhere here. I guess these are the location. This point is 180, 10. We have clearly found out the case. It's the third case in which first extreme point is inside and the second extreme point is outside the window. Now we need to find the point of intersection. Had both these points been inside the window, no clipping would have been needed because the line would have been completely inside. Had both the points been outside the windows, then also we didn't need any kind of clipping, as we would reject that line outrightly. So in this case we have to accept half of the line and reject the other half. So we want to find out the point of intersection between this boundary. Here we have drawn, we are just trying the numerical, and we know which line it is clashing with. It is clashing with the top horizontal boundary of the line. So now first of all, step number 2, as we have categorized, what we need to do is to have the point of intersection. Now we will create an equation of line for this these two extreme points. For this equation of line, as you remember, is y is equal to mx plus b, where m is slope and b is intercept. So m can be calculated very easily. This is equal to y2 minus y1. So you can take any point as 1 and the other point you take it as the second point. So let us suppose this is the first point, this is the second point. So y2 minus y1, 10 minus 100, divided by x2 minus x1. This is 180, not 18. 180 divided by 150. So y2 minus y1 divided by x2 minus x1. So if you calculate it, it is minus 3, if I'm not wrong. Now the next step is to find out b. How can you calculate b? B can be calculated by having this equation. If we fill the known values, any of this point filled in this equation, suppose I take this point 150, 100. So if I put 100 in place of y, is equal to m is minus 3 multiplied by x is 150 plus b. So you rearrange this equation and find the value of b. It is probably plus 350 if you calculate it. Right? Now we know m is equal to minus 3 and b is equal to plus 350. So equation of line becomes y is equal to minus 3x plus 350. So now equation of this line is found out. Now next we will find out the clash, point of clash. You know, this point also lies on this line, horizontal, top horizontal boundary. So any point lying on this line has a specification that its y coordinate will be equal to 20. So you, because this is horizontal line, you take any point, you pick any point and find its y coordinate, it will be definitely 20. So if we put value of y equal to 20 in this equation, you get 20 is equal to minus 3x plus 350. This way you will get x is equal to 110. So now x value is 110 and y value is 20. So this point of clash has the coordinates x is equal to 110 and y is equal to 20. So now we have found out the point of clash. Now step 3 is to redraw the line. First of all, we will erase this line and use clear device, and then we will redraw this line, and the new line to be redrawn will be between this point and this point. So a redrawn line will lie between 150, 100 and 110, 20. So when you redraw this line, this will be this, and this part will not be redrawn. So we find the clipping extra part, the part which is outside the window is automatically clipped. Hope you understand it. I advise you to try more numericals to make the concept more clear to you. Thank you very much.